was getting that plastic that's how we put it.
Yeah, I'm happy to be here once again. So today we gonna be looking into visualization. But before then, there is a particular thing I want us to talk about. In the data we use for our data wrangling, everything was a numerical data type, because in that the data we use, none of the data was categorical. They were all float and int. So because of that, there are some things we didn't do. I want us to just quickly look into them. They are very, very important and essential. So we'll be sharing another data with us today. I've shared the data before. I will share the data that we use today for both the other part of the data wrangling and visualization. So let me quickly check the data and share. Please, I'm searching for my data. Okay. Have you sent the data?
Have you shared in the chat? Or...
Yeah, I've shared the data. It's sharing now. You just don't say the
Okay.
it's loading. So that is the data we're gonna be using today. Still loading. It's loading. So oh, okay. The data is loading. I don't know how big it is, but maybe it's network. So let me just go straight and be dealing with the data. When you get the data loaded, then you can use it in your own system. So instead of me waiting for the data to be complete, let me continue. I will be opening the Google Colab, sharing my Google Colabs. Oh, please permit sharing.
Oh, sorry about that. Okay, there you go.
Okay.
Just make it close.
Are we all seeing this? Hello?
Yes, we can see.
Okay, let me just go back. Okay, the data is still loading. But from my own hand, I have the data with me. So when you eventually get the data, you should just go to your system and upload the data. And this is the name of the data. this ACTS data 2020B has been shared with you. So the first thing you do, you import the necessary libraries, the NP, NumPy as NP, pandas PD, and then matplotlib as PLT, then with the Seaborn as SNS. Those are the libraries that we're going to be using today. So after you have imported the necessary libraries, then you, of course, you load the data is a CSV file. So you load the data. After loading the data, then I call the data the F. So this is the data we're gonna be dealing with. And in that data, oh, I see the reason why it's taking longer time for it to be loaded. The data is contain 100,000. Oh, 1, 2, 3, 4, 5, 6. What is this?
Yeah, so
1 point something rows and 18 columns, right?
yeah,
You can see the number of rows and the number of columns. It has 18 columns. So you can verify the 18 columns here. These are the 18 columns. The heart disease, BMI. So what this data is all about is the data that is trying to predict if an individual has heart disease. So, and this under this category, heart disease, this column, you see you're gonna have yes or no. Yeah, you have heart disease, yes, no, like that. The BMI is also called, the BMI is called body mass index. Body mass index. And normally,
data has been shared now, sorry.
okay, you have seen the data.
Yep.
Good. So everyone can upload the data. Everybody now know how to bring the data into the Google Colab. You just go to this file, then you go to upload, then whatsoever location you have it on your system, perhaps on download, you upload it. And then when you upload it to your Google Colab, then you can come and do this. Import the necessary libraries, then load the data to the shell. So after loading the data, we call it the F. I call it the F. You can call it anything. If you like, you call it the F at disease or anyhow. So I decided to use the F, the conventional the F. So now, after loading it, I want to just inspect the inspection of this data. This is the data we have, the heart disease, body mass index. This BMI is body mass index. Of course, you have to understand what everything means. If you are in Earthline, you will understand what all this stuff represent, or you can Google it out if you don't really understand what it means. So this heart disease is just the column that is telling us about every individual from 0 to whatever the number ended. The index 0 is saying that this has no heart disease. But if you check this index 100830, you see, yes, this individual has a heart disease. And under that, the individual has a body mass index of 25.50, while this individual has a body mass index of 16.60. Then smoking, this says yes. So smokes, this one no, yes, like that. Then alcohol drinking is just yes or no. This data is, I think this one is better compared to the other data we use, because this one contains some categorical data, some float, the integer, like that. So you have some that are integer, some that are floats, like that. Then smoking, okay, alcohol, whether someone drinks alcohol or yes, whether this one stroke, whether someone has a stroke or not. Then perhaps this may, okay, well, since this is whether maybe this has a stroke or not, okay. Physical health. Okay, maybe there is a way they measure the physical health from 0 to 100. I don't know what is going to be the maximum here. Physical health, if this person is having the physical health of 3 and this is having the physical health of 20. The mental health, maybe there is a way they get to measure the mental health. Maybe there is a questionnaire. Maybe there was a questionnaire that was passed that was used to calculate the these parameters to get the mental health, the physical health. Different working. Well, I don't know what this represents by this means by different working. So, but it's just that yes or no. So I don't know what it means. Of course, if you download this data from Kaggle, if this data has come from Kaggle or whatsoever, they should have given the description of what every column represents. However, the aim here is not to teach what every column represents. The aim is to use the data. So now these cells are male or female, talking about the age category, 55 to 59, 80 or older, 65 to 69, okay? We have the race. Oh, majorly white, white, white. Okay, it's like this race is going to be like white, black, white, black. Of course, we have a lot of data that have been hidden. We can easily get that. This is diabetics, whether an individual has a diabetics or not. You have to look into the data to understand, have an idea of what the data is talking about. Physical activities, yes or no, whether individual partake in physical activities, the general health, okay? It's like asking about their general health, okay, very good, fair good, very good, excellent, very good, stuff like that. Then we have sleeping time, asking maybe the time, maybe someone sleep for 5 hours, 7 hours, 8 hours on average. Then this one also talking about asthma, whether such individual has an asthma or not. Of course, it's going to be categorical, yes or no. Kidney disease, whether an individual has a kidney disease, yes or no. Then skin disease, yes or no. These are all the data that are present, the rows in our data. 18 rows and 100,834 rows and 18 columns rather. So this is the data. But now when you're talking about visualization, we just reason like, okay, since we have gotten this, let's just visualize. Your visualization is never going to be a good one except you first clean this data. If you don't clean it, you cannot, well, you can visualize, but you're gonna have a lot of problem, because I can even see from here, I have some NA. So it means you're gonna be visualizing the NA together with whatsoever you have. Okay, you can see I have some NA. And if you look at it, you may have some mismatch. I saw something the other time. Yes, you can see this one says very good. And this one says very G. You can see. So this will represent different columns. We are going to have a category for very good, and at the same time, we are going to have a category for very G, which shows that some things are mismatched here. Well, maybe mislabeled. I don't know what I should call it anyway. So we have to take care of all this stuff before we start to visualize. It follows the whole everything we have done in our former lecture. So let's just look into the former lectures and use it to just follow it up. Okay, the first thing we do in the former lecture, I hope you can see this. These are things we did. We read the file, we check the head, we check the tail, we check the describe, we check the info, we check the shape. So it's still the same stuff that we're gonna be doing. So one of the first things we can do is to check the head. So let's check the head. You can see I'm just following up the old one. Head, the F dot head dot head. So the head is going to give you the five this is the head dot the head dot head, the first five data. So for you to see clearly, this the first five data, and you can from here you can have some inspection. Okay, this is in body mass index. Okay, smoking. Okay, physical health. This one mental health. Okay. Oh, if physical health has been measured in 3 point something, I think mental health should also be measures like that. Should not be an integer. Maybe if this is float, maybe this one should also be a float. Maybe the value has been gotten through some calculations, because I don't know how they got the physical health and mental health of the individual. So if it has been gotten through calculation, then it should be a float. So this may be a good one, but we may need to change this mental health to floats, or we change the physical health back to integer, either of the two. So I'm thinking we have to do some mismatch data type here. This is just by inspection. Okay, this year's working different working. I don't understand what different working means anyway. So, but it's just a categorical yes or no, and then cells is just female also. Be under if these cells have been filled, some people could have said,
Abdul,
yeah,
sorry, I think that thing is if the person has difficulty walking.
okay, that
That's
is
what I'm suspecting. I don't know.
difficulty working, yeah. So it means if this means difficulty working, then we will think maybe we should just rename this column so that anybody can understand. I don't understand what it means by diff working. So maybe we should turn it to difficulty workings, right? It means this column now we have to rename this column. So that is another thing that we are suspecting here. Those are things we definitely gonna do. Age categories, okay, we can check all the categories that are available, maybe less than 15 or maybe less than 18, from 18 to that, from this to that. We can easily check. Later, we're gonna see. Then this race, white, okay. I understand what this means. So we have different races there. So we can say if you have white, black, whatsoever. I don't understand the other. I don't know the different kind of race we're gonna get here. Diabetics, okay, this one is clear. Yes or no? Physical health, okay. Physical activities, yeah or no? This is good. Sleeping time, where I don't think, okay, this sleeping time can also be a float, because someone could have said, okay, I sleep for 5 hours, 30 minutes. I don't know if it's gonna be in the float, sleeping time. If it's gonna be in hour, then it's not going to be, maybe we should just make it an integer and say, okay, we only want the approximate hour. How long? Don't tell me 5 hours, 30 minutes. Just tell me it's 5 hours, 6 hours. But if you want it in a minute, then we should be saying, okay, let this just be in minutes. I guess this should just be in an hour, not hour mixed with minutes. So if it's 30 minutes, let it be 30 minutes. Oh, if it is 5 hours, let it be 5 hours, nothing like 5 hours, 30 minutes. If we want to turn it to minutes, then we can just turn everything to minutes. It means everything we have here multiplied by 60. So I think this time, this sleeping time, sleeping time. This is not what I'm thinking. Maybe sleeping time is going to be the time at which the individual sleeps, right? Someone sleeping at 5 o'clock and someone sleeping at 7 o'clock, or maybe sleeping time. This is not clear enough. This is not clear enough to me. So there could be two interpretations for this. Someone thinking like, okay, this individual sleep for 5 hours, this individual sleep for 7 hours, this individual sleep for 8 hours, this individual sleep for 6 hours, or this individual sleep at 5 o'clock, 7 o'clock, 8 o'clock. This data is not too clear to me. So what did you think? Please unmute yourself and speak. What did you think? So I'm not sure of what it represents, either the time of sleeping or the time spent sleeping. So I'm not sure. So these are things when we call the head. We can as well call the tail the F dot tail.
Abdul,
Yeah.
sorry, I have a question.
Okay.
Yeah, like when you're reading if you're reading a file into a be it Colab or
Yes.
Jupyter, yeah.
Yeah.
I don't know, it shows in two parts, the head and the tail. Yeah.
If you are reading it.
Yeah, once you read in the data, like, yeah, like
this one.
Yeah. The
okay,
next.
okay. When I just say the F, right?
Yeah, it shows the head and the tail. Yeah.
Yes, you can
So
see.
okay,
The
I was
first
just
5 and the
asking.
last 5,
Yeah, we
and
can use
every
that
other
to
ones are
inspect
hidden.
we can use it to inspect our stuff. Yeah.
Yes.
Okay.
So you can see every other things are hidden here. If you
Yeah.
want everything, I share a code the other time, but I don't want that. This code that will allow you to see all the rows. You can still remember that. So when you say display dot maximum column, display dot maximum row, it's going to show everything, but I don't want that. So you can call for the head dot head, the head dot tail. So those are one or two things we can quickly do to see how. And when you check this, you can see that we have some NA, and that we have some things that are not well, they are not matched with other labeling. Label, I think this will be a label mismatch, because I guess this is going to be very good, right? So this is going to be a very good. Now we have checked the head, we have checked the tail. Let's see. We know we're gonna have some little problem. Let's see, after checking the head and tail, what else can we check? I just want us to go with what we have. We can check the shape. Of course, we already know what the shapes look like. We already know, because when the first time we called for the F, we already have 100834 rows and then 18 columns. So, but we can still confirm by this, by checking the F, the shape. By the time you run, it's telling us 100834 and 18 columns. So we have checked that. Another thing we could do is to call for the info. Let me just copy. Why I'm doing this is because I just want you to know that you can just be copying from one file, from one collapse to another, but ensure the only difference is going to be the data you use. So when I call for the info now, the info for these, they are all these. The info as well will have summarized everything, like the number of columns, 18 columns, the number of row, 100834, and the index run from 0 to 100833, because it's 834, it should stop at 833. Of course, you're gonna see that. So, and that is just from here alone, we have discovered so many things from this point. We know the number of rows, we know the number of columns, we know the index, where the index runs from 0 to 10083, just from here. And when we columns, all the columns from 0 to 17, of course we have 18 columns, and 17. So we have this, and we also have the, from here, hello everyone, can you hear me?
Yeah, yeah.
Okay, good. Okay, someone is asking for the data in the the WhatsApp group, right? You can help to share the data in the WhatsApp
Yeah,
group.
it's been shared in the group.
Okay, good. Now, when you check this place, you already see all this. These are all the columns we talked about, and at the same time, when you look at it very well, you will know the data type of individual of everyone. And again, since we are expecting how many columns, 100834, we are expecting how many rows, 100834. This is complete. It means this has no missing values. 10080, of course, that is the number of column we have if you check this. Number of row rather. We have 100834, and when you check this row here, we have 100834. But if you check down, this becomes 100833, which shows that there are missing values here in BMI. But if you check, like, well, there is no missing value from here to here. But when you check this one again, there is a missing value in each category. So we have a missing value there, and because this one, there are no missing values in this. But when you check this last four, you still have some that we have skin cancer, kidney disease, asthma, sleeping time. You can see that it's not up to the total number of what we are supposed to have, which shows that they have missing values. So we have been able to get lots of information from here, which shows that we're going to be looking for a missing value, and we're going to be either removing them, or of course I can remove it. I can remove all the missing values here, because if I have 1008326 here, and I have 100834, so I can just remove all the missing values. It's just going to be very negligible, instead of replacing them with NA and with main media, or field back, field backward or forward, whatsoever. So I can just remove everything. The data is still going to be, because the data is massive, I will still have more than enough data that I need if I just remove all the missing values here. So this has given us lots of information. Another thing is the data type. If you check the data type here, let's say if there are some that have been mismatched. We have heart disease, which should be, do you have heart disease? Yes or no, which should be an object. It's correct. So we have body mass index, which is float, of course, should be maybe 26.50, this point this point that. So okay, it's correct, it should be float. Smoking, of course, is correct. Smoking is yes or no, it's an object. We also have we have alcohol, which is also an object. I hope you are okay. Let's do it like this. The first problem we have now is that we have missing values. We are going to deal with missing values, right? This is the we have identified these values. We have missing values that is to deal with. Now, okay, we are checking. Okay, there's another thing we identified the other time. We identified that there are things we should rename. Okay, we think we should rename different working. Okay, let's say rename of column, right? We also identify, before anything, we identify renaming columns. Renaming columns, or columns name, anyhow. These are things we identify. It's like I'm jotting what I will still do. What other thing? Okay, this is correct. Physical health. If you like, you can rename this. Okay. Physical health is float. Mental health is an integer. So I don't think this is good enough. I don't think. I think we should rather change the two to either both of them to float or both of them to integer. We can go back to it and check. Physical health, if this is physical health, okay, we can see physical health. Let's check the whole stuff. Physical health, okay, maybe we can change everything to integer because I don't think it was measured in 30.5 or something like that. So it means maybe they are either going to be in integer or in floats, or we can leave them like that. It depends. So, but in my own case, let me just reason like, let's change this to float. Let's work in float. So let's say, which one is that? Physical health. Okay, mental health. So let me identify mental health. Like mental health, I want to change this to float. To float. Okay, so I've identified that. Cells is an object, of course. Yes or no. Male or female. Age categories of we may rename these as well. We may just say age, or maybe age categories, we put space, whatever we want. Age categories, okay, it's going to be it's going to be an object, yes, because it's going to be from this to this, 65 to 64, 55 to 59, like that. So that is good. Age categories, race, of course, is an object. Okay, because it's gonna be black, white, whatsoever. Then diabetics object, I think is yes or no. If individual asks if diabetics or not, yes or no, yeah, is an object. Let me see what else again. Diabetic physical activities. Physical, but even before I continue, if you are changing anything, that should come under, if I, after renaming the column, then I can change anything that is mismatched. Then later I can now be working on the missing values, okay? What else again? Race, diabetics, and physical activities objects, general, earth objects, sleeping time, float. Please, what is your opinion on this sleeping time? I don't really get what is sleeping time. What did you think the sleeping time will represent? Please, let's just reason together here. Sleeping time. Is it the time individual spends sleeping or the time at which an individual sleeps?
I think it's the time that the individual spend in sleeping.
Sleeping, okay, okay. So then if it is time, let's just put it in an hour, then let's change it to, if it is that, then let's just change it to maybe integer, because it should be in hour. So sleep for 2 hours, 3 hours, so we are not saying 2 hours, 30 minutes. So let's change that as well. Sleeping time to integer. To int, because I think it's in floats. Let's check. Yes, it's in floats. So we have to change that. What's it again? Asthma objects. Okay, yes or no. Kidney disease object, yes or no. Skin cancer, yes or no. Okay, good. These are the things we have to do for now. Let's quickly start from renaming. Before we rename, we can as well check for the help.column. Of course, we know how to rename now. We say the f.column. The f.column. If you run this is going to give us all the columns name. I hope you still remember this. These are all the columns names. And I say, if you want to change it, this is what we just do. You just copy the same thing, the f.column, you copy it and paste, and you say it's equals to whatever you got here. This is all what you got, but just the list format of it. We say they are all equals to this. We say if they are all equal to this, then the only thing we can do, we can adjust. At this, I put a space, I rename it. Alcohol consumption, Or should we leave it drinking like that? Okay, drinking, maybe I should just put a space. If you like, you think stroke, okay. Physical health, maybe I should just put a space. Or maybe I should be putting an hyphen if you think they are the same word, but instead of putting space, there is an advantage and disadvantage to putting these words together. If you put them together, there are some things that will be easier for you to do than when you separate them. So this one, we call it difficulty working, or how do difficult, please, what should we call this one? What do you think we should call this?
Diff in working.
Working difficulty or working, or what did you call it? What did you say I should write?
I said diff in working.
Div, Abi?
Yes.
Okay. D-I what?
Diff IF underscore in working.
But
Or
the
dash
problem
in
is that div in working is still not telling us. We want someone that is not, okay, immediately you just see it, you should understand what it means.
Okay, then working difficulty.
Because someone can just see and say difference in working or something like that. Yeah, working difficulty. Okay, age category, fine. I can just put hyphen. Physical activities, let me just put hyphen. General health, I think this one is sensible enough. Sleep time, if I like, I can put this. Kidney disease, let me put hyphen. Skin cancer, of course, all these ones are good enough. I am just trying to say we can rename them. So we can still leave them, but if you think difficulty, is the difficulty correct? All these. So you run. Once you run it, if you go back and call for the data, it means we have solved the first problem we are trying to solve, the head. The first problem we are trying to solve is to change the name. We have been able to change the name to what we think is best. So we have changed the name. Next thing we think we want to do is we want to change these two columns, one to float and the other one to integer, right? So I believe we still remember how to change the column name and the column it's not name again, the data type rather. I believe we still remember how to change the data type. If you cannot remember, just scroll on this. Why I'm doing all this is because when you are working on your own and you are yet to master, you can easily do this that I'm doing. Like, okay, just find any of your data and scroll down. I just want to show you, okay, data type. Okay, where do we change the data type the other time? Okay, this is all what you're just gonna do. You just copy and take it to so why I'm doing this, you don't necessarily have to cram everything. The most important thing is that you know the next thing to do. So once you know what to do, it's become easier for you just copy the node with time. When you work with those, when you work with them, you will easily be able to remember what to do. And the one we are changing now, we are changing mental health to float. So just go back. This is mental health. You can come here as well and copy it. Mental health, just copy and go and paste it to the column's name. So what are we changing this to? We say we are changing mental health to float. So it's already in float. So when you run it, it will change the mental health to float. At the same time, we also want to change another one to integer. The one we want to change to integer now is which one? The sleeping time. So it depends on the name we call it. You come here and check the name. Okay, this is what the name that we now call it. You copy, because if you don't put the right spelling there, it's gonna flash error for you. So that is why sometimes you just have to copy it. You copy, you place, and you paste it here. You replace it, and then of course this one now to int because it was in float. Then you can say int 64, depending. And say int 64. Just say int and run. What happened? Okay. Let me just say int if it's not taking 64. I don't know what happened yet. Let me go and read what the problem is. Cannot convert non-binary value NA. It means that particular column has an NA. So before we can do anything with that, we must change, we must either remove or replace the NA. Yeah, we must do that. But apart from that, let me see. Let me just show you another thing we can do. I have a place, I explained that to us before. Under this, I have another Google Colab that we worked before, where I said that is not the only way of changing the columns. If the columns has NA, there are other things we can do. I just want to take you to that so that you can yes, I think somewhere around here I explained. Yes. You see this code? Let me copy and go back. This is our new Google Colab. You know, we want to change this to float, but it will not change it because if we go and check the mental health, we have NA values there. Oh, not float, rather integer. If you want to, not mental health, we are dealing with sleeping time. If we go and check the sleeping time, even if I say 64, it's still going to be the same. If you go and check the sleeping, if you go and check the sleeping time, there is going to be an NA there. But there are things we can still do. Let me just copy that sleeping time. Changes to BDF. This code should work. Irrespective of whether there is NA or there is no NA, is going to go ahead and do the conversion. So instead of using this dot hash type, we can as well use a PD to numeric. So let's go back. I'm just doing this because I already told us that that is not the only way of converting it. This case, what this one will do is going to, this first one, the first method that was unable to change, when it was going through it, it encounters either a string or NA or any other special character. It won't be able to change anything like that. That is why we're going to get error. Before we can run it, we must go there and remove all the special characters or change the NA to whatsoever. That was why it says NA or I or if to integer. It's difficult. So you cannot convert that. But there is another way you can convert by using errors is equals to coerce. It's going to force the error to become an NA. So if I run this now, it should run. Okay, you can see this was able to convert the data from floats to integer. Or even if it's not converting it to float, let's check. Let's go back. It's going to convert it to, let's go back. After running this, let's still say if after running this, we can now run this again, because I'm not sure. I think it's going to convert it to float, but I think we want it in integer. Let me run this. Oh, it's still the same. It's still the same. It will convert it to float and then turn everything to NA. And at that, we can only find this at float. Okay. Okay. Okay, let's check. Let's first check our data. The f.info. Yeah, I think info will do all. We do that for us so that we don't waste time. Let's go back. All what we were doing, we have been able to change the names. Then we have been able to convert the mental to floats, float 64, float 64. Then sleeping time is at floats. Yes. It will what this do, this one will always convert to float. It will force everything to float, but unfortunately it was still at float. So it can convert to float, but not integer. Before we can convert to integer, we have to go and remove the NA. But the advantage this one has is that if there are other special characters that are not, it's not necessarily NA, it's going to force all of them to become NA. So that is the advantage this one has over the other one. So anyway, we have to deal with the NA now. So let's go and check if we have NA in our data. Of course, we already know we have NA. So how do we check that? Whether we have NA or not. So we come back here again and say, check for NA. This is it. And this is not the only method. Let me go to where we actually run the NA. We say we can check if we have NA through using this heat map. So if I copy and I run this heat map, it's going to check our NA for us in a graphical manner. So if I run this, oh, sorry, did I use, okay, yeah. What? It's not showing any NA. This is not supposed to be clear like this. We are supposed to have NA. Let me check. This is not supposed to be clear. Let's check through. Okay, it may be negligible. It may be there and will not see over it. Maybe because of is a very big data. Yeah, it may be very tiny for us to see. So because the data is a very big one, a very large one, and we have a very negligible NA. You can see these are the NA that we have. We have 12, 8, 3, 3, 1. So even visualizing, we will not see it. You can see everything seems okay. I can see something like a dot here, just like a dot. I can see something like a dot on my system. So it may be difficult because it's just very negligible. If you are talking about millions of data and just maybe 1 out of the million is NA or 12 out of the million is NA, then it becomes negligible. You may not be able to see it. So except there is a way we enlarge this one. So it may just be like a dot, a yellow dot. A yellow dot stain, and we'll not be able to see it, but it should be there. So maybe we have to look for a microscope to see that. But since we can't see that, this is a good way to say we have BNA just only has 12, sleeping times 8, age this one has age category has 3, physical health 3, this one 1, this one 1. Those are the NA we have. In my own opinion, we can deal with this NA by just removing all the NA. I think we should just remove all the NA because they are too negligible. What did you think? Hello?
I agree, since it's
Yeah,
not
they
going
are
to have
negligible.
any.
Instead of going to, you just go to body mass index and say, okay, fill it with mean. And you go to sleeping time and say, fill it with, what do you call it? Fill it with median or mode. Oh, it's not necessary. They are just 1 out of 1 million. Just remove them. So in that case, we just quickly called for remove NA. I believe we still know how to remove NA. If you can't remember, we have those methods listed for us here. Oh, which data, where did I, okay, I think here, yeah. No. Yeah, I think somewhere here. Yeah, remove NA. Yeah, I think somewhere here. And if you cannot find it, of course, you should know how to remove NA by now. So when you practice, you will remember all this stuff yourself. In our practice, we talked about remove NA. Okay. Somewhere around here. This one, we are not removing NA. We are filling NA with a mean. That is not what we want to do. The only thing you just need to do is to say the head dot remove just to remove fill NA. If you like, you can fill NA with 0, but instead of filling NA, you can just remove all NA. So let's check. I put everything somewhere so that when okay, I think total data wrangling. That was where I treated everything. Yeah. Okay, somewhere here. This class is just like we are dealing with, we are doing the revision of everything we are done using another data type, because everything we are done now, okay, this is it. You drop, in dropping NA, in treating NA, we say there are many methods of treating NA. We say we can drop everything, this is it. We can drop everything. Then, if you are not dropping everything, you can fill NA with mean, which we demonstrated here. We can fill with okay, this is what I'm looking for. We can replace NA with median, with mean, with mode, with random numbers, and we can remove everything entirely. So, and the option we want to choose now is to remove everything entirely. So, if we want to remove all the NA, all we just got to do now, we already know that we have NA, so all we're just going to do is to say the head dot drop NA. So we drop the NA now. So if we run it, and of course we have run it, anytime you do things like this, you should always check. We can copy this that we used to check that we have 12, 8. If we check that now, it should be 0. Everything should have been 0. When we run this again, you can see the heart disease, body mass index, everything, we now have 0, which shows that we no more have NA in this data. Because we no more have NA in this data, we have the problem. Changing a particular column, we can go back and copy that. You see, we were trying to run this and we were unable to run because it has NA. If we go back now after we have removed the NA and run it, there should be no problem any longer. So, okay, now I want to go back and say, okay, I want to convert the sleeping time to integer. If I run it, there should be no more, okay? You can see the NA has been totally removed. So if I call for the F now, this is now the new df we have. In this df, if you go back and check the total number of rows, you can see it has dropped. The total number of rows, 100809, which initially it was, let's check. Initially, we had 100834, and now we now have 834. We have 809. You can see it's just negligible. If you have 834, that is about how many? 34, and we now have 9. So we drop about 20, about maybe 25 data, or 25, and we drop just only 25 rows that was dropped from the data. So which is good. We don't have to stress ourselves. Okay, let's replace this one with mean, replace this one with median, replace this one with that, replace this one with this. Okay, we don't have to stress ourselves. Once you have a large data and you discover that all you just have to drop is negligible, just drop them. You drop them. It's when you don't have large data that it becomes a problem. You don't drop. Every row becomes important. Although, in some cases, you cannot drop data for someone that will be dealing with a financial record, because I don't put my age. Don't make you to drop my financial statements. I hope you understand. So you have to know what you are dealing with before you start dropping. I don't put my age, then you compute. Just compute something for me. Don't drop my financial statement. The financial statement is more important than the age. Or rather, drop the column. There are two things we understand now. We are dropping rows by this. But you can as well drop the column. If you see that the column is not important, drop the column. Just drop that particular column. Okay, since I think age is not, let me just drop all the age. Since everybody are not cooperating, dropping their age, let me drop the age instead of dropping the rows of the number of people that didn't fill the age. So these are one or two things we can do. Now, if you check this, everything seems perfect. But yet, they are not perfect. They are not perfect. Okay? Hello, are you with me? Hello, everyone?
We are here.
Yeah.
Yeah.
So let's check does describe. Let's check describe. The have dot describe. So that, let's see, I've dropped I don't have missing values again. And okay, so let's check the describe. I don't have mismatch and types again. I don't have my label, what do you call it? My columns are well labeled. Okay. I think the data, they are almost good, but not. Let's check the have.describe. Describe. You know, you can see the have.describe. Okay. This df.describe is only describing to us those ones that are numerical. You can see that the non-numerical ones, they are not included. The non-numerical, they are not included. So, if you check, I'm just checking, there are other things we can put in these brackets to be able to check sometimes you can just put your cursor on it and then it will tell you some other method you can do in the brackets. There are some other things you can specify. Okay, you can see it's telling me, I'm just trying to check. You can see describe can have include. You can see in this include, you say include none, right? If I like, I can include those that are non-numerical. I didn't include the non-numerical here. That is why it's saying by default, it's including none. So if I go and set it, I can check for the non-numerical. But before then, let's quickly check into the numerical one. In this numerical, all what we have here is that BMA, the total number of count now is 809, 100,809. This one 100,809, 10, which shows that there is no missing values again. This is the mean value, 28. The mean value of this is 3.4. The mean value of this is 3.9. The mean value of this is 7.0. If this is, it means there is there any problem with sleeping time? We have changed the sleeping time to, okay, it's checking the mean value anyway. So this is at the mean value. The standard deviation for them, these are the standard deviation for them. The minimum values in this BMI is 12. The minimum value in physical and mental is 0. The minimum value in sleeping time is 1 hour. Then the 25% of the people here is this, and that, and for this is this. The 50% should almost be the half, and should almost be the same thing as mean. You can see that in BMI, the mean is 28, and 50% is 27.26. So it means they are close. Okay, it has an implication. They are close. So the most important, when this is part of the statistic you are supposed to know, the mean and the 50 percentile, they are supposed to be close. So if they are not close, there is an implication of like telling you like there is an outlier in this value. There is an outlier in it. So if this is 27.26 and this is 28.3, okay, it's good. It's good. It means the BMI, well, of course, they are not exactly the same. The outliers is just going to be very minimal here. And this is 75 percentile, and this is the highest body mass index, the maximum. The most important thing here is this minimum. Okay. At the same time, how did they get this 50%? That is 12.0 this plus 87 this divided by 2 should give us whatsoever we have here. So, and if they are not giving us, then it means we still have some outliers towards the maximum. Let's see. Let's say 87 plus 12. What is that going to be? Let's just say approximately 100. Divided by 2, that is 50, okay? And now the minimum, the 50 we got is never the same thing as the mean and the 50 percentile. So we show that something is wrong with this maximum. This maximum may be an outlier in this particular body mass index. This is how to understand the statistics of knowing if we have an outlier or not. There is an outlier in body mass index, but possibly it's going to be this maximum. This maximum may be too big. If we remove this maximum and we assume that the maximum is just 50, if you say 50, it means if we remove the maximum and say, okay, let's our maximum be 50, and we say 50 plus 12, that's just going to be about 60. 60 divided by 2, that is 27, and that is 50 by 25, which is close to this 27. So it means the maximum we have here, most of our outliers move towards the maximum. There are people that put more than the necessary body mass index. From my knowledge, even the minimum, even the minimum doesn't look at, it's not a good one. From my knowledge so far, a body mass index less than 18 body mass index maybe just between 17, 18. You can have a body mass index that is less than 18. And those body mass index are going to be referred to as underweight if the body mass index is less than 18. So if you are talking about something that is less than 18, it cannot go as low as 12. So even the 12 may even be the outlier type. So the body mass index should be, the minimum of body mass index should be around 16, and the body maximum should not even be more than maybe 60. I can't see someone having a body mass index of 87. That is a very large one. Okay, so if someone has a body mass index that is less than 18, that is said to be underweight. If it is between 18 to 25, that is said to be normal body mass index. I always check my body mass index. My body mass index is always around 22. It's always around 22. 22 point something, 21.8, 22 point something, like that. And how to calculate your body mass index is just your weight in kilogram divided by the square of your height. You just check your height, you check your weight. If you check your weight and you think you are becoming too big, never worry. First, calculate your body mass index. Check your height. Sometimes you may have a very good height that can carry the weight. But if your height is not such a good one, if your weight is, you have a very large one, then the body mass index will become very large. So the height actually moderates your body mass index. So it helps your weight. So if you have body mass index between 18 to 25, you are normal. Between 25 to 30, you are overweight. You can calculate yours, you are overweight. If your weight in kilogram divided by your height in meter square, you square it, and then you divide that. If you divide that, and if it is between 25 to 30, you are just overweight. If it's 26, you are just beginning to be overweight. 27, yeah, overweight. 28, overweight. 29, oh, you are becoming very overweight. And 30, overweight. But if you is now between 30 to 34, you are obese. You are obese. Then if it is above 34, then the level of obesity has increased. So now we are expecting something 34, maybe 40, 50 maximum from individual. And we are having someone saying that the body mass index is 87. So this is an outlier in this our data. You can see that we just use this statistic description summary to be able to talk about this body mass index, even without going back to the data. You can say, when you have this maximum with the minimum, if you divide by 2, it must be something around around the 50 percentile, or must be something around the mean. If it is not, it means there is an outlier. Okay? So, which may be coming from the maximum size or the minimum size. So, if I have my minimum around 16 now, and I have my maximum around maybe 45, then by the time we check it, it's going to fall around the 50 percentile. So, which shows that there are like about 5-10 data that are outliers here, which we can remove. So that is on the body mass index. That is the type of statistic you have to understand as an analyst or as a data scientist rather. So you have to understand this little statistic dealing with the mean, median, and mode. This is going to be the median and mode. This is the maximum. This is the minimum. This is the mean. And this median, and this mean, they are almost the same. They should be the same or very close. And at the same time, if you add this and this and you divide by 2, it should be close to the 2 of them as well. At the same time, you can know where, you can have an idea of where this tilts to. If the 50 percentile is 27, and the minimum is 12. It's closer to this 12, yeah. But if you check 27 and the maximum is 87, then it means the tail moved towards the maximum. You can see it's very large. I guess most of these outliers fall at the maximum. That you just have to remove them. The minimum seems to still be okay. Like 12. That is on body mass index. The statistic of this, let's check. The mean and the 50 percentile, oh, they are not the same. The mean is 3.4, while the 50 percentile is still 0. This shows that is very large. And go and see the maximum. The maximum is 30%. We saw that even there are lots of problem here. Around here, checking this data. At the same time, when you say 50 minimum, 0 plus 30, that is 0 plus 30, that is 30, divided by 2, that is 15. Which shows that this 50 percentile should be around 15. Then something is wrong. This physical health, we have lots of problem there when it comes to the data being evenly distributed. This is what is happening here. What this is telling us is that many people, they are not feeling their mental health is never between 0 and 2, right? And then the mental health of this, okay, 75 percentile is still 2. You can say 75 percentile is still 2. And then this one, the maximum now is now 30. You can see the gap. So it shows that the distribution is not evenly distributed. There are some most of this data focus on people with low, maybe I don't know whether the 0 represents the low. I don't know what the measurement actually means. So, but if according to what I think it should be, like 0 to like 2 should be a low physical health. It means most of the people are within this range. Most of the people are within this range. So the data are not evenly distributed. It's like you took like 100 people, and 80% of them, they are within a very low physical health. I think the same thing happens to mental health too. They have low mental health and they have low physical health. Like 80% of them, in fact, 90% of them, is only the remaining like 15% that now have a higher mental and higher physical health. Though the data is good, but in terms of distribution, the data is not well distributed. If you are using this data to build a machine learning, of course, you can represent that and say, okay, many people living in this particular region, they have low mental health, they have, okay, good. But when it comes to using it to build a model, the model will be faulty because the model will be used to those with low mental health and those with low physical health. When you want to use data, the data should be evenly distributed. Like when you are talking about mental health now, let's say like 40% of the people has a good mental health, and let's say 60% have a average or a low mental health. It's good. But a case where you are using where more than 80%, then that data is not going to perform well when it comes to modeling. So if I go and use this to build any model, the model will perform poorly in prediction, because it can only predict properly those people that have a low mental health. You can see they are the ones that are the majority. It can predict them. But when it comes to people that have good mental health now, they become minority. And the model has not been used, the model is not used to that. So these are the things we check when you want to build a model. But just for visualization, just for information purpose, fine. You can plot a bar chart and say, you can see the growth of this is high, showing that this community contains this is low. In building your model, you have to scale everything down to the same. Maybe you just remove majority that has low mental health, such that such that we have almost equal size to train our model. For example, this is it. If we have a class of 100 people, and all of them, like 90 of them, they are female. We have 10 male, and you use that data to train a model, and immediately you say, candidate number 1, say, this is a male. Oh, female rather. This is female. Candidate number 2, female. Candidate number 3, female. Candidate number 4, female. Candidate number 5, female. Candidate number up to candidate number 11, male. Again, candidate 12, female. When you bring any and you use that to train the model, if you just bring anybody from outside and say, this model, who is this? Is going to tell you that it's female, because it has been used, the female has been used as the majority to train it. I hope you are getting the aspect we are looking into now. These are the areas where you can actually know whether your model will perform well or not. But for information purpose, good. It's the data you get that you are going to present. But when it comes to using it to build model, you have to remove so many things. Even the data are good, you still have to remove them, because it becomes and we call it imbalance, data imbalance. It's not going to be balanced. So you just have to make them balanced such that the model is used to, okay, I've seen so many male, I've seen so many female. So immediately you bring anybody to be able to say, okay, look at it, look at the future, okay, this is male. And it will be 80% accurate. But if you use those ones that are imbalanced, then it's never going to be accurate. So that is what we can detect from this physical. The body mass index is good. This one, we have lots of problem with the data. Okay. Now, when it comes to sleeping time, let's get the sleeping time. On average, the mean is 7. Let's check the median. Those are the two. Okay, yeah, this is great. The mean is 7, the median is 7. Good. Good. So it means, and the only thing now is when, let's check 24 plus 1, that is 26, and 25 divided by 2, that is going to be 12. That one, we have an outlier. Someone saying I'm sleeping for 24 hours is not realistic. I hope you get that now. It means we have an outlier towards 25. You can even see the 75% is 8. So which is closer to those upper here than to 24, which shows that the problem moves towards the maximum. If the 75% is 24, and if 75% is 8, and the maximum now becomes 24, then there is a problem. If the 75% is 8, then the maximum should not be more than 12 to make this data to be realistic. This is how to actually check. Now, if I check this 24, there is an outlier here. Though the data look great, but yet I can still get something out here. Like this is 75%, which is 8. Good. And then suddenly maximum becomes 24. No, if the 75% is 8, then the maximum, that is 100%, should not be more than 12. Or around 13, 14, which is still going to be realistic. But you tell me 75% is 8, and then you are now saying the maximum is 24. No, that is not good enough. That is not good. The same thing happens here. If 75% is 31, the maximum should just be around maybe 50 and not 87. The same problem this one has, that is the same problem this also has. We have some outliers towards the maximum. Towards the maximum. Of course, the mean value is great. 50%, the 50% is 7, and at the same time, the mean is 7. This is good. This is good. But where we have problem is the maximum. The 75% is 8. If you have 75% to be 8, and then suddenly this one now changed to 24, then something is wrong. And even common sense, someone cannot be sleeping for 24 hours if not on drug or in coma. So it can't be sleeping for 24 hours. then in our data, how many people will have said they have slept for 24 hours? Maybe in the data, you can have like maybe 5 people we mistakenly say maybe they want to write 2 hours or they want to write 4 hours and they mistakenly press 24. So this could be a problem. Then it means we have some little outliers in this data. Please, you can ask your question. This statistic is very, very important. And when you come across they are telling you that you have to understand statistics in dealing with to become a data analyst like that, this is actually one of the things they are talking about. Okay, there is still another part like testing for the hypothesis. So that's those are the only statistic you have to understand and the only mathematics that you have to understand. Please, you can ask your question before I continue. Ask your question. Hello? Hello, everyone?
Here.
So please ask your question if I continue.
No questions.
Okay, good. Now, but there is another thing we have done. We have done wrongly. We didn't check for duplicates. If we have, if there is, we have what do you call it? We have duplicated rows. Maybe you gave me the data, I fill it once, I fill it the second time, I fill it the third time, I fill it the fourth time. Okay, we never check if we have had a duplicated rows. Please, let's quickly check for duplicates. Can we still remember? Can we still remember how we check for duplicated values?
No, not remembering.
Okay, please, let's quickly look into a duplicate. This is our code. Just go back and check. Or rather, maybe I should just check for, okay? In fact, don't let me even print anything. Let me just, this is how we can check for our duplicates. The help dot duplicated. We are not sure if we have some duplicated values. Oh, we have duplicated values. We have 2,000 duplicated values. So we have to remove this duplicated value. Maybe that is even why some of this statistic, by the time we adjust it, some of these things will be adjusted. So you can see we have these duplicated values. From the remaining 1.809 that we have 2098 as a duplicated value. So when you know that you have a duplicated value, the duplicated values are not too good in your data, you have to remove them. So how do we remove a duplicated value? So all we can do is just to remove the duplicate. You just see our df. We have treated all those. Df is equals to df dot remove the duplicates and keep the first one. If you have duplicated values, for example, if this is duplicated, this one also duplicated are the same. So it's going to keep this one, assuming 3 of them are the duplicate of this first one, is only going to keep this first one and remove these 2 from the data. So that is what this function will do. So if I run it again, so all the duplicated values have been removed. So if I run the def to know what we actually have in our def now, you will see that the number will have dropped by the 2,000. Now it has dropped to 98711 rows, 18 columns. So since we have this, we can still go back and check and check for our description. Yeah, this description. You can still check for this. Let's go back and check and see this time around. Maybe there are some improvements in it. Because we have removed the duplicate now. Let's see. Let's describe again. Yeah. In the describe, do we have any improvement? Let's check. This is main 28. This is 27. Okay. This is 31. This is 87. Oh, still far. Okay, almost the same thing. If you cannot read this, there is what we call transpose. If you say .t, which actually means transpose, it's going to rearrange it for you so that it will turn the row to column. Let me run this. You can put transpose to just transpose it. You can see. I think maybe you can understand this better. Body mass index now comes there. This, okay. The maximum, this is the count. The counts are the same thing. This is the mean for this particular body mass index. The minimum is this. Anyone that pleases you. I still like working without the transpose. I still love it. I still love it. So is there any change? I still love to work without the transpose anyway. Let me do it without the transpose. It's the same thing. It's always easier for me to compare. These are the things I want to compare, and I love this. It's easier for me to compare. So either of the two. Okay. I know everyone does. Visualization is one of the easiest things to do. It's just to copy a code and play it, and that's all. There is no big deal in visualization. But you don't visualize if you don't clean your data properly. The data you want to use is not going to come it's not going to come in a prepared format. You are the one to prepare the data yourself. Okay? There's something I wanted to mention, but I think I'm forgetting. Let me see if I will remember. Let me check my data here to see if I will remember what I'm trying to bring up. I wanted to mention something lately, but suddenly I forgot. So in the visualization, we are not yet going to that. Okay, let me check the data properly. Yeah, I think I can remember. Yes. Yes. Yes, I think I can remember. Yeah. You know, I said we are only dealing with what do you call it? With numerical. What about the categorical? In categorical data, you know, these are not the only column we have. It's not only body mass index, physical health, mental health, and sleep time. We have others that are categorical data, like objects. Now, you know, the other time when I said that describe, I said you can put, I was saying you can set some other parameters. One of the parameters you can set is what to include. This time around, you know, the include was set to none. I said, yeah, I already mentioned it, but yeah, you can see the include now. I now said include object. At the same time, you can even set include all, but let's treat them separately. You want to treat numerical separately from this one was easier for us to understand because it was all numerical. Now we want to deal with those ones that are objects. You can see that we have the heart disease, the smoking, the all those stuff. All these ones, they are categorical, they are not numerical. At the same time, we can analyze them. This is what it means. Count is showing that this one is 98711. All of them are 98711, which shows that they all don't contain NA, right? Now, unique values. When you talk about unique values, it's like in heart disease, how many unique value do we have? Is yes or no, right? Those are two, we have just two unique values here. And the top of them is no. The one that has the highest unique value is no. I hope you understand. It means was it 90066 of them said no. You can say it's not balanced. If you are dealing with 98711, we should have balance. We should have balance almost equal, almost 500 to say yes, and almost 500 should say no. Almost 400 should say no. If you have this, but what am I even talking about? Okay, 98,000. If we have 98,000 data, right? Out of the 98,000 data, 90 of them said no. You can see this is still an imbalance in our data. It's not too good. If it is 98,000, at least 50,000 will say no. Why the remaining ones will say yes, or the other way around? Or even at least 30,000 should be able to say yes. So this is imbalance anyway, but it has just only two values, yes or no, unique value. Since I see no, I know I have yes as well. So that is why I'm able to conclude that I have yes or no. Smoking, two values. This is balance. If you have 57 people said no, they don't smoke, okay, then it means we have about 40 something or maybe 30 something. By the time you subtract it from this, say yes, that they smoke. Yeah, it's good. It's balanced. It's balanced. So these are how to check how balanced our data are. Now, in here, drinking. Oh, drinking, 191,795 said they don't drink, right? Of course, we have just only, let's forget about whether balance or no balance. Let's just check the unique value. The unique value of this is 2, which is just yes or no. Stroke, the unique value is 2, yes or no. Working difficulties, the unique value is 2, yes or no. Sex, the unique value is 2, female, male, or female. Age categories, we have 13 age categories from 65, between 65 to 69. We have between 65 to 69. They have the highest number. So which we have about 13 categories. Let's see, we can check all of them. Let me call for, let's be checking them. The health. Okay, I want to call, okay, see what I want to do here. I want to call for this unique value for this. This is the name, put it. Dot unique values. That's unique. What? That's unique. Maybe it's just so. Okay. So I check under the heart disease. I have heart disease. I have the unique value here. The unique value is they are no and yes, or yes and no. Those are the unique values I have under that. There's something I want to mention here. I hope I remember. Let me check. I hope you understand what I mean by the unique value now. Hello, everyone. Hello, everyone.
Yeah, here, understood.
Okay, those are the unique values. So at the same time, let me check one of my data, and something I want to get out. Sometimes I want to do some things if we just but if I run through any of my code, I will remember. I'm coming. Let me check my review. Yeah. Sometimes all these things, they are just like we already have template. And okay. Yeah. 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 So let me go to another stuff. Let me say the have into at disease dot value count. Okay. Dot value count. Yeah. I hope you get the two stuff I did now. I checked, you can see this was already summarizing everything for us. Like when you check the at disease, you see that we have the at disease dot unique is having two stuff, yes or no. That is unique value. So that is why it's telling us that we have two here, no and yes. And I went further to check how many people said no and how many people said yes. Of course, this one is telling us that the maximum is that says no, they are what? They are the number of people that says no's are top, right? They have the maximum. So, and 9006 of them said no. And I confirmed by saying, check the value count. How many people said no and how many people said yes? This is what I have. 8,000 people said yes and 90,000 people said no. They don't have Heart's disease. This is what I mean by imbalance in our data. If these people are saying yes and these people are saying no, then we should have almost 50-50, 50%, 50 almost equally spread. Okay, so we can confirm that using this code, unique value, when it says two, what are those two things? Or the only thing this one is telling us is that no is the top one. But what is the second one? What about if the second one is okay and not yes? So we can actually confirm using dot unique. And we can confirm the values in them using value counts. So, and someone will just think that value count is more powerful compared to dot unique. So we can, because checking value count, we can check the unique value at the same time, and at the same time, you check the counts. So the same thing we do for this other one. If you do it for smoking, it's still going to tell us this and that. We can just change this to smoking. Let me create another one. I will not do dot unique for smoking. I will only do value count for smoking. Since we can get everything there. For smoking, I can just copy. You don't want to make mistake. And when you are copying, ensure that there is no space when you paste it. Or else it is still gonna flash error for you. When I run this, smoking says yes and no. This is good. This is perfect. If 57,000 people said no and 41 said yes, this is a perfect balanced data. For any good data, this is perfect. This is perfect. So when you check for alcohol, the same thing, you can just copy the same thing for alcohol, for stroke. Of course, all these ones that are 2, 2, 2, 2, they are possibly going to be yes, no, yes, no. Working difficulty, yes, no. But cells, we are not sure of what that is going to be. When you say cells, and you can check for the cells, this may be imbalanced at the same time because they may be dealing more with I think it's capital. Let me just type it and run. Okay, this is good. Female, 51 female, 51,000 female, and 46,000 male. This is good. This is a good balanced data. So the unique values now in cells are female and male. But now we are going to get problem where we have a unique value of 13. Okay, what are these unique values? Unique values. If we have 13, we are not sure. All we know is 16 to 69. That is the highest, which covers this. And we have other 12 that we don't even know what they are. We can use these same unique values to check. I hope you are getting the point, right? You have to do all this for all your data before you start printing, before you start using any chart on them.
Oh, I see. I have to check the data.
Okay, so let's see the categories. The categories are 65 to 69, 70 to, okay, 60 to 70 to 75, 55 to 59. Okay,
Oh, a bit more.
this one happens to, okay, no, 80 or older. We can go, we can as well go and change this 80 or older. We can go there and say greater than 80 if we like. We can label that one. I hope you understand. If we don't want it this way, but it's nothing bad. So these are all the categories we have under that. But there is one, okay, the race. Under this race, we have six here. If we have six, what are the races? What are those races that is talking about?
Yeah.
Right? If we don't run this, we are not going to know, except we go through the columns one after the other. So all I will do is to copy for the race. This interests me. I want to know what are those things under the race. Then all we have been seeing, it was white when we were checking by inspection. But now, okay, we have white, we have this, we have that, we have other, we have this, we have that. So these are all under the race. Those are the six. If there's anyone we want to change, like others, we can just change it, like Asians, like black. If you like under the black, okay, we now have
Different races.
America, Indian, all those stuff. So, okay, these are all what we have under the race. So good, but it's imbalance under the race. 72 white, right? Which is imbalance. If we have C's, what we should just do is like we should just divide, like, since they are 100, and if you say divided by 6, it means at least each one of them should be nothing less than 15,000. If we want to make this balance, each one of them should be, okay, let's just say between 10, each one of them should not be less than 10,000 to make this balance. They should not be less than 10,000. But imagine this is taking 72,000, which shows that this model is more used to the white. If I use this data to predict, it's going to be used to the white data. And every other data becomes minority. It may not predict all these other ones correctly. It may not predict them correctly because the model basically is for the white. It's going to be for the white. It will predict anything about the white correctly, but it won't be able to predict. In fact, when it comes to Asian, it won't be able to predict anything correctly under Asian. It's just 3,000. It was only exposed to 3,000 and was exposed to 72,000 of the other one. So these are the things you check in your data. That is just for a model, for building model. It's not for your presentation. You don't need all this in presentation. All you just need to do, this is the data, plot your chart. This is what the number of these people we have here. This is what we have here. This is what we have here. Which shows that more white patronize us than compared to every other race, and this and that. That is how you just give your story. But when you want to deal with what do you call it? When you want to deal with with model, then you have to consider all this. You don't want a model that will be biased. We don't want a model that will be biased. For your model not to be biased, all these things have to be balanced. Okay, like the yes or no, the first one is not balanced. It's used more to people that has no heart disease, which shows that it may not be able to predict heart disease correctly. Smoking is used, okay, this is balanced, 57 and 41. Yes, it's balanced. This one is balanced, says 41, and assuming they treated it with 90%, 90,000 female and maybe less than 5,000 male, it won't be able to predict anything male properly. So, but for this, it will at least a model that has been exposed to 46,000 male is good. 8 categories, and that is how to check whether your data is balanced. Now, this one interests me again, diabetics. Normally, we are supposed to have yes or no, right? Hello? Hello, everyone?
That's not looking on this thing.
Hello, everyone?
You're here.
When we go to
Yes.
diabetics, when you check the data and you check under diabetics, it is supposed to be yes or no. But now, yes, you can see diabetics. You're having yes, no. How come we have 4 categories? Do you understand? You can see. But here now, we now have 4 categories. Something is wrong. It should be yes or no. But I think what may be wrong is going to be something we discussed the other time, where somebody is putting capital letter yes, small letter no. I hope you can still remember that. That may be exactly the same thing that just happened here. Let me go and copy it because I don't know what's going to be the right spelling. You always copy? You always copy and paste. So it's interesting just for you to know what to do. Once you know what to do, the code is not a problem. Even if you don't know the code, go to ChatGPT. Tell me I want to do this. Give me the code in Python. It's going to give you the code. But the most interesting thing is you know what to do at the right time. So there's it. The same thing. This one said diabetics. No. This one said yes. This one said no, borderline diabetics. This one said yes, during pregnancy, right? So for us to overcome this now, we should just change anything that is contained no to no. This one, we should add them to no and add, or what did you think? And add this one that says yes during pregnancy to yes. Of course, we have gotten different type of diabetics, type 1, type 2, gestational. I think these people, they are on gestational diabetics. So that is why they tend to just say yes during pregnancy. They always experience diabetes only when they have pregnancy. That was why they specify, yes, I have diabetes, but not always, only during pregnancy. So we could, and the only thing we require is just yes or no. So we just add this particular one, we add them to yes, and this particular no, borderline, we just add them to no. They already know that, okay, with what they have, they might likely have diabetics with time. That is why they said borderline. So, but presently it's still no. It's still no. So perhaps we just add them to no and add this other one to yes. We can do that. So any other one that interests us, you can see how we call on does describe can help to give us a statistics summary of our both numerical and categorical. In numerical, you understand how it helps us to dictate whether some are going to have outliers, some are not having outliers. We can get that from here. And here we have been able to dictate some that are distributed equally, some that are not well distributed, and at the same time a mismatch or misname or mismatch label. Yeah, maybe I should just mismatch label like this. Yes, yes, only when I'm this. No, when I'm that. Or even some can even use small letter no, and some use capital letter yes, and then at the end it becomes a variation. So we can add them together. So that is what we can do here. So we have noticed a problem here that we must address in this diabetics. We must address this particular column in our data. So before we address that, let's quickly look into other. What is this? General head 5. We may have to address this as well, because general head, I don't know. Okay, well, it may not need to address. It will to be addressed. It may need to be addressed. But before then, where do we stop initially? Diabetics is 4. Physical, okay, actively, this one is just going to be yes or no, which is good. This one, that is 5. We are not sure. Let's check under the general head. Okay, asthma, good. Yes or no? Kidney disease, good. Yes or no? It's just 2. This one is just 2. The only one that may actually have problem is this general head. Let's check. We are not sure if it's going to be a problem. How come do we have 5 if we have very good? From where? Is it poor, average, good, very good, but I don't know. Let's check. You can check that. You quickly go back and check for counts. I copied that so that I won't go up again. Let me copy this. You see, it's interesting. It's just to copy and paste. But know what to copy at the right time and what to paste at the right time. Oh. Okay. I want to check what is inside the general head that is making it 5. Okay, these are what I got. Okay, very good, fine, good, excellence, fair, and poor. Okay, good. We don't need to change anything. The only column we have to work on is our diabetics. In this diabetics, what should we do? We are supposed to change the good to good, and what do you call it? The other one. Those one that says only when I'm this, only when I'm that, we are supposed to change them. We are supposed to change them. How can we do it? How can we do that? Or did you have any suggestion? All I think I want to do, I want to check if for every column in this diabetics, in this column that has diabetics, if we have anything in it, for every column in that, if we have no, we can change the no. If we have, we should just, if anyone that contains no should be totally no. Anyone that contains yes should be totally yes. I think that is one thing we can do. And if you want to leave it like that, since they just think they only have diabetics when they are during pregnancy, then you can leave it because it's still a type of diabetes. We will call what do you call it? Gestational diabetics. So you can leave it like that if you want. So, but the principal thing we want to do now is after we have checked and we have removed data, we have checked and we have removed what do you call it? NA. We have checked everything and everything seems good. We can visualize some of these our data. How do we visualize? One of the things we can plot bar chart. We can plot pie charts, histogram. We can plot what do you call it again? We have been plotting heat map. We have been using heat map. So my heat map is not correct though. We have been plotting heat map. What am I typing? Is it correct? Heat map. We have been bar chart, pie chart, histogram. Which other chart did you know? Line or this line graph? Line graph. We can. All those are things we can do. So how do we do that? What can we, how should we do that? So let's start one after the other. So even if it is just two we plot today, in our next class, we can, because I can see is time already. Wow. Let me just plot one and then explain some things before we go again. Yeah. Let me just plot one so that in our next class, we can plot others. Since we already have data that has been cleaned. So since data has been cleaned, let's just plot like one of it. And one of these things we can plot now is, let me see, the simplest one to start with. And just check mine and see what we are going to start with. Okay, we want to start with bar charts. Let's go to bar charts. So if we want to plot a bar chart, let me just copy a code and we modify. This is the code. And this is what we want to modify. What do we want to plot? A bar chart. Which category? Let's plot for body mass index. Body mass index. I think that was what we call it in our data. The health body mass index. Which values are we plotting? Which values? It's going to be the body mass index dot count. We have the count here. Dot body dot value count. That is all this one against, we plot whatever we plot against the count. Whatever we are plotting against is count, like you have y-axis and x-axis. On our y, of course, x comes first. So body mass index, although this is not going to be a good one, I will tell you why it's not a good one. We are not having the categories for a body mass index. Is going to be a continuous data. Values, okay. Let's run this. And it doesn't run. What happened? We have a little problem. It's not a good one because we are dealing with a continuous values. Okay. Instead, let me plot another. Let me just use another stuff. We have a problem with this count because we did not try to sorry, I'm coming. We did not try to categorize our body mass index. It is not every plot that is appropriate for every column. For example, if I want to, let me choose a column that will be realistic so that I will now explain what I mean. Let me choose cells. Okay, let me just use this column. Of course, we already have male and female. There are some that is going to be the line graph that will be good for it. There are some that is going to be the bar chart that will be good for it. There are some that will be going to be a pie chart that will be good for it. So you have to understand that we are getting a continuous data, and we have gotten they have dot cells. This one is still the have dot cells. Sorry. Label, what I want to give it, just maybe I should just say cells, x-axis. Sorry, this one, what did I want to, maybe I should just put it, I just copied this one from where I was doing sentiment analysis. So this one, maybe I should just call it gender. I don't know. So you can call it anything. Let me run this and explain what I've done. you will be seeing some things that you don't, the dot. I'm using dot notation. I'm going to use the other notation we all understand now. Why? It's taking long? Now, before then, let me just copy the code and rewrite and rerun in another while that one is running. So this is the one we understand. When we want to get the cells, we use this and you put this and say cells. Okay, it's still the same thing. When you either you use the bracket notation or you use a dot notation, it's the same. So it's the same. I don't know why this one is running forever. Is it network? I don't know. I don't know what is wrong. And I can do nothing except that stops. So now, while that is running, I was talking about categorical data and continuous data. If you check this our data properly, and even from here, you can see that all these ones, they are continuous data. All this one, they are numerical data. Why these other ones we have here, they are categorical data. All this one we have here, they are categorical data. They are categorical data of the type yes, no, female, male, very good, all those stuff. That is why they are categorical data or objects. But now this one, they are numerical because they are figures like integers and float. There are sometimes it is better we convert our integer to float and our numerical to categorical, and we have not done that. That is what we are going to be doing to be able to use some form of chart. I don't know why this is running forever. This should have by now. plt.bar, plt.xss. This is the only one we even need. Every other one is this one is just telling us what should be the labels on the x-axis, and this one is the labels on the y-axis, and this one is the title on top. Okay, you can see. This one is telling us that we have gender, okay, cells, okay, some that are male, female, cells. Maybe we can change it. I don't like, you see, it's not really making sense. Let's change it and put the X for Y. When we will have x-axis, let's change it. Let's remove that and plot this one on the y-axis. I think that should make better sense. And let's run. It's gonna take forever. We can use the other notation here. Let me copy this as well. The only thing we have done wrong, I think, in that one, what we have done wrong is that what should be on the x-axis, we put it at the y-axis. I think that was the only thing we have done wrong. Now, all these things, they are not compulsory to put the label, whether x-axis label, y-axis label, the title, they are not compulsory. The only thing we only need here is plt.bar and then plt.show. So we can do that. You can just remove them. It's not going to tell us anything on the y-axis, anything on the x-axis. So that is when it comes to visualization. We'll be dealing in our next class. We'll be dealing more. We'll still have one more class on visualization. But before we continue with the visualization in our next class, we will learn how to convert our numerical data to a categorical one. For example, it is important we change this body mass index. Where do we have the body mass index? We change it to category. Like this body mass index, instead of having 16, 20, we can just classify it into like 4 classes or even 3 classes. On the way, anyone that is less than 18 should be categorized as underway. Anyone that is between 18 to 25 should be categorized as normal. Anyone that is between 25 to 30 should be categorized as obese. If it is greater than 35, okay, if it is between 35 to between 30 to 35, should be maybe morbid obese. If it is now, I don't know, let's just maybe we just classify it into like 4 or 5 like that. I hope you understand. So that is always very important sometimes for us to have a good visualization. So I think that is the only one we can classify here or categorize here. Well, like this mental health, assuming you have a very good mental health knowledge, you could have classified this one as well. If it is less than 2, maybe poor mental health, poor health. If it is between 2 and 4, maybe, but that is if you have the knowledge. Like I don't understand the measurement, so I cannot even do anything. Yeah, the best thing you can use to represent this kind of you can use maybe some of them you can just use line graph to understand and to represent them, line graph and things like that. So there are graphs that are appropriate for categorical. There are charts that are appropriate for numerical. Okay, you can see it's better now. Gender. You have this gender, you have female, you have male, you have count. I call it cells. If I like, this one I call gender. This is it. I can call it anything I like. It's the title. You are the one that will be calling it anything you like. But I don't want to alter it because it's like this one. I call count. I can as well call it frequency if I like. Frequency. So this one I call cells. That is the x-axis. Okay, yeah, on the x-axis. I hope you get that now. This is how to plot a bar chart. And I think this is, I don't understand why I'm having equal.
Yeah, the probably other
You
one.
understand? Because from the data, it's not supposed to be equal. I hope you get that. It should not be equal. Something is wrong. Something is wrong because from our data here, so it's wrong. So we are going to stop here. In our next class, is since we have been able to clean all the data, in our next class, we just start one after the other and take every column. We take the heart disease, look at the best data, the best thing we can use for it. We go to BMI, the best thing we can use for its own representation. We go to smoking, the best we can use for it. We go to alcohol drinking, the best we can use for it. We just reason, let's use bar chart for it. Let's use histogram for this. Let's use pie chart for this. Let's use this for that. But whether this is correct now or not, maybe something is wrong. You can see it takes some time. Maybe I have to restart my system and something like that. So, but you have an idea on how your visualization is going to look like. This is what you should expect in your visualization.
To look up.
Okay, this is how it's going to look like. All you just have to copy a code and paste. That's all. So in our next class, but before that, our next class, under our body mass index, I want us to know how to do binning. BIN, to bin it to a particular category. So we should learn that. It's very important. Sometimes binning your continuous data makes your machine learning predict better. Okay, it makes, and sometimes it makes your visualization better. It's going to be good when you have your body mass index and you just see them in 3 categories. Okay, underway, you have lesser people underway. You have between these are okay. These are the people that are overweight. These are the people that are obese. These are the people that are normal. So it's going to be easier than to have series of numbers. So sometimes it's better to just convert to categorical. So we are going to talk on how to convert to categorical, and we are going to deal with a lot of stuff. So we are going to stop here for today. So let me rename this visualization. Let me just call it visualization. Thank you for coming. I think we are going to continue from where we start in our next class. Thanks. can I ask your question?
Thank you so very much, Abdul. Yes, like Abdul said, if you've got any question, please feel free to ask. If we've got no question, then we would call it a day and see you all next week. I don't think we will be doing the Friday classes, so unless we get a lot of people showing interest and wanting to catch up. But if not, we'll meet same time next week. Yeah, on this platform. Thank you all.
All right. Thank you, guys. Much appreciated.
Thank you. All right, goodbye, everyone.